start with some definitions, what SOA or SOA means. Well, it stands for Service-Oriented Architecture. And Service-Oriented Architecture and the SOA term has been around for quite a while. But at the beginning it was overhyped, in my opinion. Some of the IT vendors sold it as kind of a product, some solution for all the problems that people might have. And as usual, that leads to a lot of disappointment in the real world. So what I'm trying to do today is first try to explain what SOA means, what a contemporary SOA means, what standards it's based on, and then why this can lead into an agile approach, an agile enterprise IT infrastructure approach, which finally can also meet with some agile development procedures, which I think can meet somewhere in the middle. So I've been around in the IT industry since a long time, starting for IT companies in Germany. And at that time, we used to do lots of specification work with all kinds of tools that existed at that time. So we spent sometimes months talking to users, stakeholders, all kinds of people, top management, then documented all this and came back with such a piece of stack of paper, went back to the offices and started developing. So after a year we came back and showed the user what we did, and the first thing was surprise, surprise, they didn't like it because they didn't find themselves in there. So we thought, well, here's the specification, it's all according to specification, you signed it off. But anyway, I said, well, I can read this, so we want something else. And in the meantime, because it took so long, requirements had changed and things like that. So right now, this agile approach is something that I think is coming out of the real world, although that when the time was when I was starting with this stuff, there were no tools around that would support this kind of approach, where I think like rapid prototyping is one thing where you can in an early stage present something to the user, how this will look like, as far as it is a user interface developer. It's probably not for everything, like if you are developing a control system for a nuclear power plant, you will probably not go back to the end user after 30 days and say, okay, is that what you don't want? But in most cases today, given all the tools that we have, this is an approach which I think is viable. And nowadays, like big companies like GE adopting this to get products and projects sooner to the market. And as we all know, the market is changing so fast that you can't spend like 2 years developing something and then come back and showing it to somebody. So my approach today is that I think SOA is one of the candidates to provide technology for an infrastructure that makes the agility aspect much more viable in an overall IT infrastructure in a company or even between companies. SOA is not only intra-company, it can also, because of the technology behind it, used for business-to-business applications and so on. And they are also changing very rapidly. So I would like to talk about, as I said, about the enabling technologies that are behind SOA, and also talk a little bit about why are the current business systems not agile. And there's a lot of reasons for this, which I will talk about. And then how we get to that agile infrastructure using the SOA architecture. And when I say this, I think SOA is one way to do it. It's not the silver bullet for everything, that's clear. I'm an independent consultant and I'm not promoting some technology or product or so here, but I'm also talking about what you can do with it, what is possible, and as I said, how SOA supports an agile development process. So what is about the impact that SOA puts on a business that adopts it? And as I said, this is not an easy way. You have to do a lot of work to get there if you don't have it already. So it's not like implementing a few apps and then everything is SOA. It's really, which I will explain later, sometimes a very hard process to do this. But when you once have done it, then the ROI of total cost of ownership of a lot of systems will become much more productive and much more easy to achieve. At the end, I will talk about some examples of SOA-based solutions. These examples are from the real world, where I was a member of an international cooperative project sponsored by Eurocontrol and the FAA for the aeronautical industry. And this project was done within the OGC, the Open Geospatial Consortium. This was during my time when I worked for Agile Systems here in Vancouver. And it was quite amazing that within 6 months we developed a system with about 9 or 10 different organization companies all over the world, and people worked together, never had seen each other. And at the end, when we went to the test bed installation and demonstrated the system to the stakeholders and the sponsors, it all worked. It was really amazing, and this is because these web services that we used there were standard web services. There were standard specifications. We used standard data model based on XML. In this case, it was GML, the geographical markup language. And so I will explain how this looks like at the end. And yeah, after that, we can maybe then discuss a few details where you may have some experience with this or what your experience is doing it or not doing it. So what I think here is necessary is agility versus engineering, and I think engineering here means software engineering and over-engineering. You know, so you can sit down for months and draw UML diagrams and everything until the last detail, and by the time you're finished, the thing is obsolete again because the user has changed his mind. But also, I think SOA has to meet reality because, as I said before, there was a lot of hype that was promoted by some of the vendors, like at that time, BEA, IBM, now Oracle, which owns BEA now. They thought that they could sell this to their organization users to solve their application integration problems very easily, which is possible, but it's not an easy way to do this. So as I said, like the users, they want to see something, and when they see it, they want to change it. So what this does here, I think what is important in this area is to enforce short release cycles to incrementally show the user what's going on, which also means that the user I mean here, which might be an end user, it might be a stakeholder organization, it might be a department, a company, it might be the external organization, it might be for a product in an IT company that wants to sell it, where the product manager is responsible for what it's actually doing. So I think when these guys look at this in the early stages, they take also some responsibility for it. They cannot say after everything is finished, well, this is not what I want. They have to do it right away. So and also what I think it's a good idea, especially in the SOA world, to start with a test plan, because that forces the user to really think about what he really wants, and he has to define at least an abstract test suite that will match the requirements that he has. And if that doesn't work already, then you already have a problem there, but you detect this in the early stages of development. Right? So then also, like normally in an engineering world, when you once have finished the specification, say this is it, now no changes anymore. If there is a change, the product scope will change, there will be lots of discussion, why is this necessary, so it doesn't matter, it's much less work to do the change. Follow these guidelines. Okay, then I also am a fan of tools. Use all kinds of tools that you can to visualize what you want to do and to present it to the user. I had cases in the past where we draw all this kind of UML diagram and show it to the user, say, is that what you want? Yeah, this is what I want, and then you finish something and say, well, this is it. No, that cannot be. Well, why not? Yeah, this is what the specification UML. Well, I can't read the UML diagrams. So anyway, what I promote here is that I will show you this later, like showing them a business process diagram where they can see what is the information flow, what kind of tasks are involved, and I don't think this is something that even an end user could understand in the early stages. Yeah, and what SOA really is also about is reuse of existing components. As I will talk about later, these business components are encapsulating business logic and other things. And when you once have designed these components, then you can reuse them on a higher level by decomposing or recomposing solutions that are using these components. And to do this, you need some layers, which I also explain later, that are based on web services, so that the interface to these components is clearly defined. And this is, I think, the most difficult part in getting to a SOA infrastructure, is to define these interfaces. So going forward, just some information of what SOA is or what it is not. As I said before, it's not a technology, it's not a product, and it's not an easy tool for application integration. SOA is an architecture for distributed processing. There are other architectures for distributed processing as well, like Core. The difference here is that SOA is, in one case, platform agnostic, so SOA doesn't care whether you run a Windows system, a Unix system, a Linux system, an IBM mainframe, whatever you have, SOA will interface to this, and it's totally separating your implementation platform from SOA. SOA is also based on standards. This is the web service stack, protocol stack here. Let's mention this later on. Lots of specification that extend the SOAP protocol, the Simple Object Access Protocol. I mentioned SOAP here sometime later, but I didn't explain what it means. In this case, SOAP, as I said, was standing for a Simple Object Access Protocol, but this is not used anymore. So the SOAP term is itself now, because it's not simple. There was a little bit of a mistake to call it that way, but the SOAP term is still alive. So as I said before, based on web services, that means you can use SOAP or even other protocols over the web. So whether that's an intranet or an extranet, doesn't matter. The whole thing is message oriented, so you are actually decoupling all the functionality from each other. These single components or composite components don't know anything about each other. They have to be stateless. You're sending them a message, something will happen, you will get a response, or maybe you don't get a response. But that is defined in the web service description. So it's also XML centric, so everything that goes across the wire is XML. Certain modular standards or not. I also will mention some examples of XML-based data models. One I already mentioned, which was GML. And yeah, it can be used also very nicely for data integration work, where the web service actually encapsulates a data store, which might be a relational database management system of any kind, might be an XML database, it might be a flat file system, anything, but the web service is always looking the same. So you can use this like to retrieve some data out of a service that exposes some of these data, depending on your request, in the response. So my example at the end was using that in the prototype project we did using the WFS, which is a feature service that delivers GML features after a request. But it doesn't have to know where these data are stored, how they are stored, or whatever. It's a defined response that you get when you request this data. So some definitions. As I said, it's standard-based. So SOA based on some of these standards I mentioned here, like SOAP, XML, and WSDL. WSDL is the web service description language. WSDL is quite, it's only used if you use SOAP. So if you use a REST approach or something, there is no WSDL. But I think that, especially in like a B2B scenario where the applications talk to each other, it might also be internally, SOAP is the better way to do it because it has a lot of advantages using this. One thing is the whistles can be stored in a registry, they can be discovered, and you can retrieve this whistle file, look what it does, what is that service doing, generate a client application for it during runtime, and access the service. So this is not really possible with REST. The other thing is that SOAP has a lot of other extensions that are defined in these web service protocol stacks, like web service reliable messaging, web service security, things like that. So if you have SOAP messages going outside to other services that you don't control, there might be a good idea to impose some security measures on the message level and not only on the transport level. Like most web services, when you see you have an HTTPS, this is a transport level security measure that you have, it's point to point. But in SOAP case, the SOAP message might pop over several servers outside of your control, and you don't want that somebody capture the message, interpret it, change it, whatever, and send it on. So SOAP and these extensions that SOAP supports can prevent this via signatures, via encryption, and things like that. So this is why I still think there was this, in the industry this big discussion about SOAP too complex, and REST is much better. But there's so many tools available right now to generate SOAP messages, to generate whistles and everything, that I don't think this is an argument anymore. It has more and more advantages over REST. REST is fine if you have a Web 2.0 application running, facing a user and talking to like Facebook or whatever, Google, but in a business case, which might be your own services that you run, I think SOAP is better. On the other hand, like this is also very important here, the service location transparency. You don't have to know when you develop the system where these services reside. They might be, outside or the other side of the world. They might be within your organization. Only at runtime you resolve the binding of the SOAP messages, which then is described in the whistling file. So I will talk about some technologies that support this as well. So for the user developer, it's totally unnecessary to know where these services reside. Can be on the same machine, can be somewhere in Africa, whatever. So another thing is important, and I will also talk about this later, is that we have what we call service units and composites. The service units is actually the atomic business logic encapsulation exposed as a web service. But these single components can be composed into much more complex units, which then address user requirements and business processes and so on. I think this is also one of the major things here that enables agility, where you can use this. If you have these core components that apply to your business domain intact and wrapped into messages and web services, then you can reuse them in different ways by using, and I will talk about this also later, like using a business process execution layer, something like that, where basically even the end user can change the flow of control using these composite applications and make changes themselves. Okay, one thing, as I already said, is the functional decoupling. These components are stateless. They don't know anything about each other. There's no dependency between component A and component B. The component itself does something very specific, but it doesn't know what the other guy is doing. So only the higher level, which is called the orchestration level, they know what is actually going on. This means this is really enforcing reusability of these components, because if you make a change in the implementation of the component without changing the interface, it doesn't matter. Nobody cares. You can even change a Java implementation or a C# implementation below, and the interface stays the same. It doesn't matter. But then we have what we call the coarse-grained functional interfaces. This is a higher level where we have to prevent can I say this? Before SOAP or web services, there was a protocol called, for instance, RPC, which is a remote procedure call style. This was calling functions all the time, so there was a lot of traffic on the wire going back and forth to call all these functions. And given XML is very verbose and not the fastest way to process something, the industry came up with the idea we need cross-grain function interfaces, which means, and I will bring an example also from the OGC later that explains what this means. So basically, you put a lot of functions into one interface, and whatever you send to them, they will find out the ones that they support and then execute this. So anyways, in the end, all this leads to very loosely coupled application components, and I think this is one of the major things that prevent agility in development. As everybody knows, like object-oriented programming was argued that it will support code reuse, and it never happened. In my experience working with all our developers was that they, before they look into what the code really does, they reinvent the wheel and do the same thing again. So then you end up with a lot of code that basically does the same things, but they don't know of each other. So what then happens if you make a change in one of these things, and they depend on each other, and sometimes the whole thing breaks. So you can come up with agile procedures as much as you want. If that breaks the whole thing when you make a change, this is not really what anybody wants. So this is one of the major features of SOA, that it really enforces a loosely coupled approach. And then the business layer can implement or map to an implementation that is also, as I mentioned, totally independent of how you implement this, what you do under the hood. It really separates this in a complete and secure way. So what are the technologies that can be used? Not necessarily, but this is something that SOA can be built on. One thing I already mentioned all the time is web services, it's messaging. So usually you have some kind of message-oriented middleware running under the hood. That could be JMS, the Java Messaging System or service, can be anything else. So, but it means that there's no call to function and the caller waits until the response comes back. So you're totally decoupling this. You send this service a message, and in the message you define whether you actually expect a response or not. So, which is called message exchange patterns. You can define this in the listing file as well. But anyway, this is totally asynchronous. So you send a message, you get something back or not, and you're not waiting for anybody. If you make a function call or something in a normal programming language, this blocks you at that thread. And so if the other guy doesn't respond in time, you have a performance problem. Here, you send messages around, and the messages are expected, and that is called routing. You can define who is getting this message and who is concerned about it. And this is done by a routing service, which inspects the message and then says, okay, this is for this guy and this is for this guy. And the overall authority that guides all these is the orchestration level or layer, which I'll show later how this relates to the other things. But the orchestration is the central control point that determines the sequence, how these components are executed, in what sequence. It also depends, it keeps the state of this functional transaction. It is a transaction at all, because the component itself are stateless. So you cannot put state in components, you have to put it in a message. So this is what orchestration is all about. It's called correlation in this case, where you keep the state and keep control of who had to respond to a certain request and where do you expect some results or maybe even an error code back, and then handle this in the orchestration level. Yeah, the web service description language is one major stone there, which tells you exactly in form of an XML document what this service is all about, what it does. And a WSDL file has two parts. One is the abstract part, where you define the abstract functions and messages that you will be handling with this service. And then there's a concrete part, and this concrete part actually points to an actual implementation service with an endpoint address where actually this service is residing. And this is what I said before. During development time, or at that time, you don't have to know all this. And further there, if you have like an enterprise service bus running all this, the enterprise service bus will determine at runtime where the service actually is. There's one technology as enterprise service bus implementation I mentioned later. This is GBI, the Java Business Integration. There you have the message that goes across the bus is actually the abstract part of the WSDL 2.0 document. So at that time, you don't care about where that location is, where this message is traveling to. You can change it any time, and ESB is finding this service by looking in its own registry to see what is actually the addressee of this service. Another thing for SOAP is that it handles, or it can be used over multiple transport protocols. The usual one is HTTP because it's the easiest way to run through firewalls and all these kind of things, which was one reason why CORBA wasn't faring too well in this area, because it will hit firewall restrictions, and because it's a binary format, the firewall cannot detect what it actually is and it will block it. So SOAP over HTTP should be a problem. You can use port 80 and then everything works fine, but you're not limited to this. You can use JMS, the Java Messaging Service. You can use SMTP, the Simple Mail Transfer Protocol, FTP, whatever you want, because SOAP is not bound to a protocol. REST, on the other hand, is bound to HTTP because it uses the REST HTTP header commands like get, put, delete, post. These are the basic four. This is one thing that REST is restricted to, but nevertheless you can combine these technologies when you have a service that supports a REST request and then you use it in your overall application. But normally, as you have seen, SOAP would be the better approach. Then there's a BPEL, the business process execution language, which is actually used in this orchestration layer for telling the orchestration service what this workflow is all about, what is the business process that is handling all these composite applications here, and how the components, the individual components have to react to each other and interact with each other. Here's a picture of a GBI, a typical GBI implementation. You have here in this example 3 departments, USB running in each department, and they are coupled through binding components. So Department C can transparently access the service in Department A, and Department A can access the service in Department B and C and in itself. So it's really totally transparent to the implementation of this business logic where the services actually reside. So this is an internal organization here within the enterprise, but Department C could as well be somewhere else in another company. As long as you trust this company and you have in place some security measures, you can do that over the binding component that I have another slide explaining a little bit more detail. That gives you an infrastructure that is very transparent to the end users and to the system itself. So that is just one example. So now I'm coming to a few points where I think why are the most business systems are not Agile today. One thing is they're monolithic and not decoupled. There's big systems out there like ERP systems that are one piece of software that interact with one big database, and to get a change in there, if you even get a change in there, if it's not a proprietary product, it's very hard to find out what are the dependencies in the software. And to make a change, and that's why the term in IT comes, never change running system, it's very, very dangerous to do this. So this is because the dependencies of all these modules are so intertwined that it's very hard to find out what dependencies are there and how they interact with each other. And to break something is very, very likely. Otherwise, we have like hard-coded dependencies. As I said, there is one class calling another class function, and there are systems out there that minimize the risk a little bit, like the Spring containers, where you do inversion of control and dependency injection, stuff like that. But it's still, you know, these configuration files can get so complex that it's very hard to control and to see what are actually the dependencies that are actually going on. Another problem is we have redundant data silos. That means I had a case for a manufacturing company where we wanted to implement a new shop floor control system, and we analyzed what they're currently doing in terms of resource planning for the manufacturing process, things like that. And we went through all these departments in that company and found out there were 30 applications doing the same thing in different departments, using the same kind of data, but they were all redundant, all inconsistent. You know, even the data itself would not explain what it actually is. The semantics and the constraints of it was only known to the application. And to look into all these things was just a nightmare. I think that is something also to solve here, which I think is a good idea to start here to provide this kind of data integration services where you expose your data as a web service, which then explains itself what it means. And also, like as I said, in the code, there is business logic in the code that acts on the data in the database. There might be like column 1, and column 1 has 1, 2, 3, 4, 5. So it's kind of a flag or a status, but what does it mean? Can I put 6 in there as well? What happens if I do this? You know, so this is one of the major things that happen in practice where you stumble, you know, across these kind of problems. And the next thing is the platform and technology doctrine. You know, we have the system running on Windows Server, and putting this on a Linux system normally is a problem as well. Then out of this whole thing gets a very hard thing to maintain, and as probably a lot of people know, most IT departments are involved in maintaining their existing software. They have no time to do new things because they are in the backlog maintaining their current software. As I already mentioned, there's redundant code. The code itself, the application is not interoperable, except you sit in front of the screen and retype in the data that you have expected from another application if you want that. You cannot talk directly to the application. I also mentioned already the semantics of the data are buried in code, so you know, it's not obvious what the data mean. So and the whole thing is not scalable. You know, SOA application is scalable because it doesn't matter how many services doing the same thing are running. And you can scale them out. You can put them in the cloud if you want. I think after my presentation, there's a presentation on cloud computing. And in terms of cloud computing, I mean a virtualized platform where you can elastically put, you know, implementation of services in and also take them out again if they're not necessary anymore. So, you know, cover peak times of transaction peaks or something like that. It's very easy with SOA. If you have SOA, it's no problem. If you have these monolithic applications, you can probably buy new hardware and put it there as well. It's, you know, put more memory in your system, whatever, but it will never really solve the problem. So SOA, on the other hand, there's a clear separation of the business layer and the technology layer. And the business interface layer can be developed in close cooperation with users. You can show them, you know, what is the business process doing, what is the business process doing, what is looking like. I have an example later from a travel agency that has to talk. There's one guy that wants to reserve a flight, a car, and a hotel for his travel endeavors. And the travel agency software talks to different organizations like the airline and tries to reserve a flight seat on that particular date. At the same time, he wants to have the car ready at the airport, and obviously he wants to have a hotel. So all this is done in the business process at the travel agency level, and they are talking to the services that the airline, the car rental, and the hotel is providing to these guys. So it goes out to the internet and is executed, or comes back with an error message if something is not available. That also means that because of there is a business process modeling language, which is called BPMN, Business Process Modeling Notation. It looks a little bit similar like the old flow charts, where you can graphically design your business processes. And I'll show a slide later on that, how that looks like. And this graphic representation, I think, can easily be shown to users, saying, okay, this is what happens, and is that what you want? And if you want it, then you can convert this into a detailed program, which is actually an XML file, interpreted by a detailed service, which I also show later on that interacts. So I think this is one way where you can also do a simulation and testing without having to implement anything. So the user can really see in an early stage what is actually going on, what will he get. So and also the interface definitions, like the whistles, they are inherently documenting what the business function is doing precisely. So you can look at this. There's graphical tools available that actually show what the functions are, how this works together, what are the message types that are involved, and so on and so on. So if you do this and you put this whistle in some kind of a discovery registry, then you also have, for the whole company, a good repository where when somebody needs a function or a business process component, you can look in that directory and see, okay, it's like the yellow pages. Who is providing, new part orders? Then you can look in there and say, oh, this is the service that does exactly that. So there's no way that you should come along and say, okay, we need to implement this, because it's already there. You can also, like getting weather information, for example, that was something we did in this O2C project. You can access the service of the NOAA and say, okay, what is the weather pattern for tomorrow for this location, and you get the response back. And all this can be discovered in the registry. In this case, it's not the old registry, it might be the registry of the NOAA, but you can still access this because it's also a web service. So you can actually interact with this and find out what you need. If you don't find anything, okay, then you probably have to develop new one, but anyways, coming back to the interface definition language, then you can clearly do this and show whoever is involved, is this actually what you want? On the other hand, also new business functions can be implemented without disturbing all the other functions. So because of this orchestration layer, we just decomposing and decomposing the new function, and it will be handled by the system. Because the other components don't know about this component anyways, they are not disturbed. They cannot be involved in this, and you get your functionality without changing anything in the existing files. This is a diagram that shows about this layering, what I was talking about on the business process layer. There might be an ESB running, which handles the composite web services, or let's say in this case order processing, one composite web service for billing processing, and these things map to the components that do the business logic on the component level, which are still web services. Here in this case it's just the 4 web services that I just used as an example of how this works. And these web service endpoints, they're actually calling the API of the actual implementation on the lower level where you have your Java classes, your C# stuff or whatever. And so if you have to change something here, and the interface here stays intact, these things here are not involved and stay the same. So, yeah, some repetition here, but I think it's generally documented as visitors. So if you have this registry service where you can search for components that you have already implemented or that are implemented by somebody else, you can look through this and find what you want. Then you can retrieve, when you find something that you're interested in, you can retrieve the WSDL file, generate your client code on the fly, and access the service. So there's a lot of tools available that enables you to generate client code or server code. There's two things here. When you talk about SOAP, for example, there's an approach which is more the top-down approach, which is called contract first. So you say, okay, I define my interface, my web service interface, before I even do coding. So when you have that contract, you can generate the server or the client code from there, which is the actual language interface, not necessarily implementing all the business logic for sure, because there's still some work to do there, because the interface definition cannot know what you want to do. But you have all the the infrastructure available to you to have, like the Java stubs, the framework for the Java code already available, or C#, whatever it is. And the same thing is true for the client. But there's another way, like in application integration, you normally have already Java code, for example. But you want to expose this code as web services, then there's the other way around. You take the Java class definition or the interface definition, and then you say, generate me the WSDL file from this. And this is quite nice because I did some data integration services, and I used some tools to generate a WSDL file on top of a relational database management system. So it automatically generated me all the WSDLs, the XML schemas, and everything to retrieve these data from the relational database management system. And at that point, at the WSDL side and at the interface side, then after that, nobody really had to know what is behind this, what is this database looking like, what product it is, and is it Oracle, Microsoft SQL Server, or whatever, and what is the actual structure of the database. So this is quite nice things that you can do. And for sure, if you have existing applications and you want to expose them as web services, then you have to do the code-first approach. You have to put a wrapper around your actual implementation code and expose it as a web service and also as a system. So one thing, like in Agile, I read this statement like if you don't know, user knows after 30 days what he doesn't want. In this case, he can interact with the prototypes of these services. There are simulation systems and tools available where you can show them exactly what's happening and what's going on before you even start coding. This is the example. It's a little bit hard to see from there, I think, but this is a BPM graphic implementation. This was done with NetBeans. This is an integral part of the NetBeans IDE. And here you see that this is a BPM program, which will then be translated into a VPEL program that interacts with the airline, the vehicle, rental car organization, and the hotel organization by sending them messages to their exposed services and getting the response back. Depending on the response in the WSDL, in the VPEL program, we have some branches there. We react if there is, for instance, no car available at that time. We do different things, like if there is a car available, the hotel is booked out, things like that. This is something where you can also, I think, in a graphical way, show the user what is actually going in there, who is interacting with whom, what is happening there, and when these things are clear, you can then say, okay, generate the VPEL program. This is something, just an extract of this is how it looks. It's an XML file that is human readable in theory, but well, basically the user will not go through and understand it. But anyways, you can see what is going on here, and then this file is then deployed in the VPEL service and will be executed. And to change this, because it accesses the same service from the airline and so on, the airline company partner doesn't have to change anything. You still talk to the same services. So So business process automation, that's what it's really all about. We want to automate business processes that, like whatever it is, a supply chain automation system where one supplier of an automotive company has a certain depth of production and needs still parts from another company. So if there comes an order in for his parts, he knows, okay, I need the other parts from this other company. So I can automate this process by sending this other company a certain message, accessing their services for the order processing system, and then provide my response to the company that has all of my parts after I got the response back from the other company and telling, well, this parts can be delivered at that time and it costs you so much. You know, and this is also handled in the orchestration level very easily, or easily. Nothing is easy, without interfering with all the other services. So in these external services, like the supply chain system can go down a lot of paths to the maybe raw material supplier and come back over 5 nodes or so to give you the information that they're requesting without knowing that there is 5 other guys behind the next one that is handling this. So orchestration is a very powerful tool there. It controls the execution flow. It can be simulated in the early stages. So process automation can be staged in an early phase of the project or the product, and users can be involved right away, which poses some responsibility more or less on the user as well. So because you can see what's happening, it's really up to him to say, okay, this is what I really want, or this is not what I want, but if I get this, then that's what I want. So you can make the change right away and then reiterate through that process so long as sometimes the point is reached where you say, okay, this is actually now what we want, then you can start implementing this. This is a diagram showing this a little bit. You have this business process orchestration service on top. This is a typical diagram showing the process and has a start point and an end point. This tasks here that depict something, they point to web services, which then comprise the actual business logic that is executed. And as we saw before already, these are then mapped to implementation classes. And I say implementation classes, I did not mention that this must be a certain platform or something, it can be anything. In Java, in the Java world, it's normally done with the JAX WS, the Java API for external web services, which automatically translate the WSDL part to an in-core representation of the WSDL file, which then is used to call the actual functions that you have implemented. So this is the upper part which we saw before, resolved or implemented in an ESB layer, where you have the DeepL engine, which is translation. You have a transformation engine normally also involved, which is UCX XLT, which is a translation. Sometimes you need to translate. When the message flows through your system and components, it has to be translated so that it's understood by some outside service. So this is automatically handled by the routing of the routing facility of the ERP. For example, if it's in USB, it can be something else. And then the message, if it's a message that points outside, it can use, for instance, the HTTP client and service endpoint to promote this message outside of your implementation world to an external service, which might be that airline organization or something else. But you don't have to care about this. On the DeepL level, you don't even know where this thing is going and that it uses the HTTP protocol to go outside. You can define this, as I said, in the WSDL binding, but for example, the USB can also determine what actually is available. Do I have the HTTP service? That's not available. I use the JMS bindings, for example. And the other way is an EGB bridge, where enterprise Java beans are used to handle web services. Nowadays in Java 6, also in the Java 6 compliant container, you can just annotate your Java classes and make them web services. It is automatically generated at runtime. So it's not a big deal anymore to implement a web service when you have some Java beans or enterprise Java beans. But I said, this is only since enterprise Java beans release 3.2 are not possible. That is the annotation where you have to use a program. This is a picture which I stole from Sun. This is the Java GBI runtime environment running in a Elastic application server container. And this connects, as I said before, the EGB world to the GBI world. And you have this service engines here, the SEs. There's one for detail, one for translation, an SQL service engine, which I said I used for accessing database management system tables and structure via web service implementation. There's an IUP that was something like stands for Intelligent Event Processor. This is something that was probably done for the finance industry, where you have complex events and the stock quote goes up or down. You want to react on this in milliseconds because it costs you a lot of money if you don't get this event. But these events are not singular. They are coming from different sources, and they have to be correlated with each other before you can make a decision. That's what the IAP engine does. So the other guys on the right side here are all binding components that are all protocol converters to the outside world. So as you see, there's an FTP binding component, GMS, file, HTTP, JDBC, MQ series, which is the IBM message queue series, SMTP, and so on. There's lots of others, but this is just the ones that are on that picture here. And you have a bridge to the EGBs, which is the Java EE engine on the left bottom there. And the NMR stands for Normalized Message Router, which means, I mentioned this I think before, GBI uses WSDL abstract files to communicate with each other. So the message, when it goes in the bus, is normalized to that format, and when it comes out, it's denormalized again. That's the way that the ESD can interpret the message that goes through the bus, because it's always looking at the same structure of this definition file, and can do the routing and all these other things that it has to do. So another slide explaining some of the Agile development procedures to that technology. So you can actually keep track and pace with the business demands that we all know are changing rapidly these days. Your suppliers or other companies that work with you change their environment, and you have to react quickly on this. Given the web services that you provide, you can do this in most cases without re-implementation of your business processes by adding new functions to the business process level and so on. So normally, if you can't do this in a very short time, you may lose that customer or whatever if you cannot provide this stuff in a timely manner. So in this case here, it's much more easy to do this than if you would have hard-coded applications that have to be changed. You can look at external components, like for instance, as I mentioned, the stock market. If you want to have a quote of the current stock of a certain company, you can access this as an external web service, get a response back, and react on this. Nobody would come to the idea to implement this themselves. It's already available. Then you have the service registry available. In the early days of SOAP, for example, there was an approach by Microsoft and IBM to provide public service registries, which were called UDIs, Universal Directory Discovery and Integration things. they were not very popular, so not used because I think the time was not ready at this stage, and they dropped it again. But UDI is still alive as an internal registry service, so you can put your existing web service and Vista files in a UDI registry, and then make them discoverable as white pages, yellow pages, and what they call green pages. Green pages is more showing what the actual functions are that are behind this. Yeah, as I also said before, the API layer can be changed without affecting the business layer. If you do this, let's say you move from your company is bought by another company, and then the new company that owns the whole thing says we don't use Windows servers here. So you have to remove all this stuff and implement it, put the Linux or Java-based server below there, so you have to re-implement the APIs that you had before with new software. But as long as you don't change your business layer interfaces, you're not fine, but it's much less work to do to achieve these things. So also this means that for integration work, they have legacy systems running on a mainframe or something. You have to integrate this, like the mainframe might be a pain in itself because it costs you a lot of money to maintain these things, so you have to change this. But you want to keep the functionality intact, and you want to keep the interfaces intact. So you can move this whole thing to, let's say, a Linux-based system, and re-implement the APIs behind the web services that you used before, going from an IBM IMS system or 6 system to whatever transaction processor on the Unix system is available, and then we implement the API layer. And then the other parts that are on the business process layer can more or less get intact. And as well, that business processes need to be expanded with new functionality. You just plug it in, and you don't touch the existing functions and components that you already have, because they are independent of each other. So here is a diagram that shows a little bit about where I think is really the Agile part of the whole system. This is like the user interface level here as a web application server UI, following model view controller architecture that keeps state of the sessions that the user executes against this service. And to change this with new functionality, you just put new links in the controller part that points to web services that goes through the this protocol layer here, transport protocol layer, and then to the business process web service layer, where the orchestration takes over and fulfills this new function. But this layer can be incremental, so you can put new stuff in there without involving the upper layer, the user interface layer. But if that changes, these guys actually don't care too much. So this is an approach where you combine, like this could be using REST here from the client to the application server, and on the bottom you then backgas this to a SOA protocol driven approach, and using heuristic files and all what services are available for you to implement this new functionality. So the user can then be shown what is going on in the early stage of the development process by just implementing something on the new controller module over there, and then this approach also, I think, supports more or less Agile development process. And this shows here a little bit of a, like I mentioned, the registry service, the service locator somewhere, on the ESB or as a user interface where you can search for certain Bristol implementations. You normally search on the abstract Bristol part where you can see what this web service is actually doing. And then you retrieve this implementation class and the web service, the concrete part of the web service, and generate a request, because you can generate the code that does it So there's some other registry services available. One of the services that I also mentioned a little bit later is the EBRS and EBWIN. That is an OASIS standard. OASIS is an organization for the advancement of structured information systems. A lot of these web service protocol specifications are controlled by OASIS, so you'll see this all over the place. And but anyways, this is another type of registry service that can be used because it's a web service in itself. You can access it from the outside, depending on where it resides. But it doesn't really matter because it can be run over the internet. You can have your own internal registry service available in your organization. You can use the other company's web service registration service if you want, whatever you need. So it's really, and the thing that the registry service does and why it does support reusable code is that you have this functional atomic functions, which are the business logic units, and you have your composite applications. This is all raw data at the moment, but then you put metadata and XML schemas on top of this, which explain what these things really do. And then you go further down, you have service semantics that tell you actually what this service does. And then the next thing, in that registry, you can build up an ontology, which means a classification scheme that shows you, okay, this is the service that handles order processing, but then there are sub-services that relate to this one. But you search for a very specific thing, you can go down and drill down to the ontology level. Ontology is practically something that explains what this thing is. But these ontologies are easily mappable to the registry data model. And this data model, in the case that I mentioned before, it's in the OASIS data model is called EBWIN. It's the Electronic Business Registry Information Model. And this defines basic data structures and data content that you have to expose to be able to do this location search for the services. And this basically then represents your domain knowledge. In that registry, if you do this, we have all your functions registered. This is basically reflecting the whole knowledge of the company. It's really all what you do. Like every process, everything, if it's in there, can then represent what the company is, what it does. And you can expose this to the outside world if you want. Normally you probably wouldn't, but so Agile procedures mean Agile infrastructure. Talked a lot about what I mean by Agile infrastructure. We have this latest business components. This enables reusability. So before you start coding a new function, the first look is already something available that does the same thing. Well, if it doesn't exactly the same thing, maybe you can use a composite to compose the same function with two basic functional components that will then do the same thing. There's no dependencies among the business components. They don't know anything about each other. So there's not that component A calls something on component B directly. It always goes through the process layer, or the orchestration layer. The business process web services should be coarse-grained because composed of a lot of functionality that is actually then mapped to this basic core components, but this prevents you from constantly sending small messages back and forth to the service. If you want to call function A first and function B and so on, you can do it at the same time if you have a coarse-grained interface. This is kind of a best practice in the industry when you use web services. Use a composite approach, coarse-grained interface on the business level, but then map this to fine-grained components on the lower levels. So that means then for the user, if you have a use case diagram or something, you can just check the use cases against the business component, see whether all the use cases are handled by the components that you already have in the service repository. The requirements, for example, when you have to composite services, and that we need to do a gap analysis to say, okay, is there something like this certain functionality that is done on the specification level, on the use cases level, or on the requirements level. So if there are tools that check this, and you can then easily see, okay, this functionality is nowhere implemented, neither as a web service nor as an implementation class. So this is a diagram I did with Agile tool. This is a graphical representation of the business process. It's a very simple one. I didn't have that much space here to show. So there's an inbound request coming in. There's some checking done, and then we do some tasks. We do some validation, whatever, and then the outbound message goes back to the requester or to another service on another web service provider. So this shows that, for instance, in this diagram, a user or business analyst can easily see what this business process is all about. There's no code to review or something like that. This is giving a simple example, but even if it's more complex, you can easily see what's going on. And then when you have that checked and done, and you say, okay, looks good, then you convert this into an XBDL file. XBDL is an XML process definition language file, which actually contains information about the graphics. So you can send this file to another tool, and these guys can see the same diagram. It's a little bit like XMI files. XML interchange files, but it also contains the business logic. So we can use this file to simulate the business process and actually show the user what is going on there before you can start, implementing something. This is just an example. I couldn't show the whole file here, but it shows you that it's XML, and there are tags in there that are always the same if you are talking about XBDL. So the strategies towards this Agile enterprise approach is, you have interoperability between ingenious systems without creating dependencies. You should create a data integration layer to avoid redundancies and inconsistencies via web service approach. I think I mentioned that before. You don't access your database directly via SQL or JDBC or something like that. You just wrap it into a web service layer. You reuse your business components in the business process layer. As I said, you can easily show this as a graphical representation of something going on there. So then you should define, if you can do that, this is probably one of the most difficult parts going to SOA, is to define a general data interchange model and format in an XML document. So that means create a data model that contains or can contain all data and semantically in the structure level that you do use in your whole organization. If it is not possible to use a standard data model, which I show you later, there are a few available. One of them, for example, for business to business was the EDXML, the electronic business XML specification, which was meant to replace the EDI binary format with XML. And this is basically used for business-to-business transactions. So not using any human intervention in there. And the next thing, if you can use EDXML, then you probably should use it because it's already defined. There's XSV files, XML schema files available for this. And the advantage is that if you use this format, then you can validate it against the XSV files that are already there. So you'll prevent anybody from using the wrong data structure that is not compliant with this data model and schema, and that prevents you from sending messages that are not valid to the outside world, for example. It saves you a lot of trouble. So this is the project I talked about before. This is a slide from the OGC, the Open Geospatial Consortium. What we did there, it was done at the time when I was working for Dallas. I used the engineering report for this. But you see there's these different organizations that, like University of Münster in Germany, they did the event service. It was an event-driven SOA system. That means if something happens on the database, an event will create it. And if that event is of any interest to anybody on a flight to somewhere, you would get it as a notification. So what this thing was supposed to do was that you have flight plans. So every commercial airline, they have flight plans. That means they have to document what the flight route is, what are the corridors they have to use, what are the destination airports, what are alternate airports, and so on. So what this scenario was doing was that the pilot, when he enters the plane, he subscribes to the event service saying, this is my flight plan, so my flight is from 8 a.m. to 22 p.m. in the evening from Washington DC to Stockholm, in this case, it was the scenario. So that means he's not interested in any change events that happens before or after that. He just wants it during that time frame and only within the flight corridor. So if something happens like Mount Everest, erupts, whatever, it's not on his flight plan, it doesn't matter, he doesn't care. But if it's on his flight route, then he does care. So what these guys were all doing, like the NOAA was providing the WIXAM, that's the weather exchange information model for weather data. There's another one, the NU, there's another weather data, WFS, IWFS is a web feature service. That feature service is a web service that is OGC specification compliant. It delivers geospatial aware data. And in this case, it was geospatially aware data for certain areas where certain weather events could happen. So then we had a company in England, in the UK, called Snowflake. They also provided the WFS, but they served AIXM data, which is the Aeronautical Information Exchange Model. This is a profile of GNL, and is also used for the exchange of aeronautical flight information data. It's a very complex data. Anyways, and then the clients were built by, there was a company called Carbon Project in the US, Lucia is a Belgian company, PC Electronics was a little company in Los Angeles, and Lufthansa Systems. Lufthansa Systems is the IT department of the Lufthansa airline. And all these companies work together independently to implement this. And so we had a telephone conference every week to check whether everybody was making progress. But after 3 months or so, we had the first test bed in place. So, you could use a client, like a smartphone client, or there are specific flight information systems on board. We could actually see, this is your flight route. There, we track this, tracking is not new, but you could then see, okay, if something happens, like we had this scenario that the destination airport in Stockholm was closed because a fire happened there. So during the flight, this pilot gets the information from the event service because it matched his subscription that there's something happening at his destination airport, and he might not want to fly there because he cannot land. So he was asking for an alternate airport, which then eventually, I think it was Oslo or something like that. And there was another problem, but it disappeared during his flight time. So all this information was sent to what we call the electronic flight bags. This is replacing the actual paper that they currently still have, so in an electronic visual form. And so we have I think there's a demo on the OGC website which you can look at that shows you the whole thing. But what I want to say here is that all these organization companies, they use this standard implementation of the data model, the web services, and I was just in the middle organizing all these things and writing the engineering report at the end. But these guys have never seen each other. They did not know what the other guys are doing. you know, and at the end, after 4 months, we had the first implementation running, you know, and after 6 months, the project was finished. So if you can imagine what this means here, this is, you know, a system that is highly complex, but using all these standards enables you to come to a, you know, a running, reliable, scalable system without, you know, involving anybody or any dependencies between these organizations that work like this. And so there was never any question, well, you know, how do I have to implement the WFS here? It's clear because it's a standard specification. So one thing is that was really, and this is, you know, we are talking about the aviation industry here, and there's an organization like ICAO, the International Civil Airline Consortium or something, that has to define all these standards worldwide. So there's like countries like Germany and the US and Canada that have the technology to implement this, but there's other countries, you know, like somewhere Chad or whatever in Africa that have no of these technologies available. So we still have to have this, you know, paper done. But what this means here is nowadays that if you have the actual access in technology, the airlines can now access this already, getting the weather information, for example. Most of the flights in the US are delayed because of weather. And the airspaces get more and more tight because the traffic is increasing tremendously, and the airspaces are not managed on an event basis, they are managed on a space basis. That means you can only have so much airplane at the same time in the same airspace, because you don't really know where they actually are at the moment. This will change, you know, and this is a lot of things that happen here in this scenario where we will save the airlines a lot of money because they will save fuel, a lot of fuel, if we can, you know, sequence this correctly and give them the right information at the right time. So that was what it is all about. As I said, it was amazing that, you know, this worked. I met some of the guys on the final conference, but before that, you know, nobody knew about each other. They did never directly speak to each other. They just implemented against this specification. Yeah, here again, then I said standards. There are a list of standard message formats that can be used if you can use them to work independently on all sides of the development process. Service registry can provide all the information about existing core business functions that are already there, like the WFS that I showed in the previous slide. If you inquire against this, then you get from the WFS via the registry a capability document that tells you, okay, I have data for this kind of features. Features is a GML term for real world thing. It can be a tree, a building, you know, a tower, whatever, a runway, and it has a geolocation or coordinates assigned to it, and it has a geometry. So a runway has a certain geometry, for example, and all this can be inquired via the registry against the WFS. So if you want to get data from a certain area, you can say, okay, give me all runways that are in this bounding box with these coordinates, and I want to see certain other attributes that are encoded in that format, and you will get the information. So you don't even have to know what this service actually provides instead of data. You can ask it, and then you will respond to this. So there's a list of given standard XML data models. The one I already mentioned is the XML, the electronic business XML format. Then in the previous slide I mentioned AXM, that's the information exchange model. It's based on GML, so GML is the basis data model for this, the geographic markup language. Then in the States, there is something like what we call NIAM, the National Information Exchange Model, which is used by government organizations to exchange data through their web services. And this is a growing data model. It was started, I think, for the justice system to, you know, tell the other country legal system that a guy from the prison such and such escaped and is now on the way or whatever. But it's now growing into a general standard information model that you can use to preserve and send different information, whatever you use as a subset of this information model to other organizations' web services. Then there's a thing like CAP, which is the Common Emerging Protocol. This is an OASIS standard. It's used for, what it says, alerting when there's an emergency, like an earthquake or something. We use this in Canada for also kind of an alerting protocol. This is used by, for instance, the weather network. So there's anything that happens like, tornadoes or something, they use CAP to send that to other organizations in the area, and then they can do whatever they want to do, call an emergency, close roads, whatever. But it's a standard format, so we know what is in there, where is what decoded, and what is the format. And although I personally think it's not a very good data model, because it's really all optional stuff in there, and you can be 5 megabytes long, it can be 3K long, so it's not a really, what I call it, a well-designed model, but it's a standard, so you can look at the OASIS website, get the specification, get the XML schema file, and then you are compliant against this common emerging protocol data message, which is also used by police and all these emergency organizations and so on and so on. So what I want to say is here that if you find something that fits to your needs, then take it. If not, try to make your own internal data model that handles all these information needs in web services, because then different departments, different organizations in your company can work on their own and develop against the standards. And they don't not necessarily always talk to each other. How do I do this? How do you want that? It's clearly defined. So there's a list of other standards. Some of them are already mentioned. The EVRIM, this is the Registered Information Model. OGC took this model and extended it for spatial queries. And it's called, in the OGC terms, WRS, the Web Registry Service. But it's basically the EVRIM model plus additional objects that tell you the spatial part of the whole registry service business. And then for interoperability, there is a standard called WSI. It's the Web Service Interoperability Organization that defines the standard, and there's a basic profile. If anything is compliant to that basic profile that they define, you can be sure that the other organization's web service can handle your request. Because SOAP 1.2 and WSDL 2.0, they are not supported here, so they are on the lower level. It's the lowest denominator that they define that everybody can handle, from mainframe to the Windows systems to Java systems, whatever. But every time you look for something that is guaranteed interoperable with other outside services, you look for WSIP, the basic profile, and if they are compliant to that, you can be sure that you can use it. Then there's another OASIS standard called the Service Component Architecture that is also kind of a composite architecture where you can compose business logic into business core functionality in a very well-defined way. And this is also platform independent, so you can implement your services in different languages. It's similar to the GBI standard, but just another standard. So in some, I think it was enforced by IBM and Oracle, but Microsoft didn't want it, so it's not that much used at the moment because they didn't want this kind of stuff at that time. There's something like the SDO service data object. I said that we should expose the data as web services, and this is one way, the standard way to do it, to encapsulate it into a service data object. This is a sub-standard from this one here from the SCA level, but it's also used outside of SCA. It has become a standard for promoting and sending around data in a very defined way. It's basically more or less an XML file enclosed in a kind of a Java object, for example. Yeah, then the Java Business Integration Standard, that's a Java Specification Request 2008, 208, which is release 1.0, and the GSR 3.12 is version 2.0, and 2.0 is a reference implementation of this. So, and this is used by all implementation that are implementing the GPI standard, which is, for example, attaching a service mix, it's the open USB from Sun. The problem with that is that Oracle has cancelled it because they want to sell their own products, because this was open source, and Oracle wants to make money. Larry needs another airplane or something. And but there's open source and commercial products on the market that support the standard. And if you have this standard, you know exactly how the interface looks like, how your routing works, how your service transparency works, and so on. And then we have some WASIS and W3C standards that are in addition to the SOAP specification. I mentioned this at the beginning. I think you have, for instance, AWS addressing. This is an extension of the data tags that go into the SOAP header that shows you what are the actual addresses, the endpoint addresses that you want to serve and when you want to respond back. Because in HTTP, you have this in the HTTP header, but if you don't use HTTP as a transfer protocol, you can't use this. So you need something in the SOAP message itself that does the addressing. That's what this thing does. Then we have the AWS policy. This is negotiation protocol. You say, okay, if you want to access my web service, you need to provide me a credential if I get to in or not. So this can be inquired before you send the message, or when you send the message, you get a message back with some of the policy statements saying, okay, you cannot just access me, and I want to know who you are. And then they initiate policy or protocol how to do this. That is what is specified in the policy. AWS security, also mentioned before, basically security on the message level, because the message in the SOAP message can travel various hops and various services that are not under your control. Only the endpoint that you actually want to address needs to know what this message is. So we want to protect it against manipulation, and we want to protect its integrity, and we want to make sure that the receiver knows where the message originally came from. So we sign it, we encrypt it, and things like that. And this is done in a very specific way, because it's not that easy to encrypt an XML message, because XML has specified tags, but you can have various amount of blanks in between. You know, it's not, if you run an encryption algorithm across this XML file, and it's not changed, but it is, let's say, presented in a different way by it goes to another hop, the encryption file doesn't match anymore, because there's a blank in there all of a sudden, because it's all text. So this is defining some way how to canonically do this. There's a canonical form of XML, which you have to adhere to be able to apply security. And then, for sure, because we have only messages that are sent to the other participating function in the whole system, we need to make sure that this message actually arrives, that it should arrive, and that it doesn't get lost. And that the message, when it is, let's say, chopped into, because it's too long, it's chopped into different parts, that it arrives in the same sequence and it is sent. So that is what reliable messaging is doing. And this is also additional data that go into the SOAP header, and it defines what the recipient should do with the message, and whether it has to respond to the message or not. Not always do you want to respond. In most cases you want, because you want to know whether that function is actually executed or not. So again, some statements about this orchestration level. This is one of the major points in SOA that you have available. Because otherwise, like a SOA possible that uses what is called choreography, which means that both parties are talking to each other, but both know about each other. So there's no way that the other party receives a message that doesn't know what it is because it knows the other party. So this is a different approach, which I think is not a good benefit here. So orchestration is the way to go. So business logic also can be defined on the implementation layer without affecting the business logic on the business layer. The business development tools do not have to care about the data service layer. You provide this data service layer that can be done by the database guys that first grab all the available data in web services and the business person data is how it's structured, things like that. So overall, this increases the productivity of development and gives you a kind of market for the product from a company that sells something throughout the world, because the overall environment is changing so fast that you cannot go back and make specifications and implementations take a year or so more, because the meantime the standards will have changed, the audience has changed, and so on and so on. So I think this is some of the things to consider here. And so the last thing is, as I mentioned, in that OGC context, this is an example of a cost-training standard web service. The web feature service supports our group operation, and create, update, and delete on HTML features. How these HTML features are actually stored is not of its business here. You can use the relational database, MySQL, XML database, whatever. We're just talking about the web service layer here, which defines how this is all done. And the other example is WS. I also mentioned this is an extension of the UVM model, and it also defines how the queries have to be formulated and what to get back on the response. So, and all these specifications are open for everybody to look at from the OGC website. So, that's it. Now we have no time anymore. So excuse me for